Good day, class. Now, up to now we have learned how we can write some conditions like if and if and else, and some flow comments such as for and while. Now, we want to learn how we can combine some of the decisions and conditions that we have. For this purpose, we are using some logic operators. Now, let's get back to our MATLAB. If you remember, we have seen some logic operators before. You should be familiar with logics such as AND, or, not, and we want to see how they are working. Now, assume that we have an operator, but have a variable like a, and a is equal to 1, and then we have b is equal to 0, and c is equal to 1, and d is equal to 0. Now, we want to look at how we can use the AND operator. Let's see what is a and b. A and b should result into 0 because the AND of 1 and 0 is 0. Now let's see what will happen if we want to calculate the AND of a and c, which means that AND of 1 and 1. The AND of 1 and 1 is equal to 1, as we were expecting to see. Now let's see what will happen if I am ANDing let's say a 0 and 1, and the result will be obviously 0. And if I am ANDing b by d, which means ANDing 0 and 0, we are getting 0. So the truth table of and or and not will be also appear in the supplementary material on the module, but you can always test the and or and not operators in MATLAB. So you already have seen the symbol that we can use for AND. Let's see how we can use OR. OR is pretty simple. We can have A, let's say, or B, and in order to do that, for ORing, we have to use a symbol which is similar to this. So two parallel lines is OR. So now I press the enter, and you see you will get A. We know that ORing 1 by anything will result to 1. Now let's OR 0 by 0, which means D or B, and the result will become 0. Now the other thing that we have to see is not. Let's see what is the not of A. A we knew was 1, so not of 1 is 0. Let's see what is not of B, which was 0 before. B was 0, so not of B will be 1. So we can have not of, let's say, A and B or C. Now the result will be 0 because B or C is 1, A was 1, 1 and 1 is 1, not of 1 is 0. Now we have seen these logic operators. We want to implement them into some conditions. We want to see how we can use them. Let's clear our screen, and let's also clear all the variables, and let's open a new M file. Now let's read variable a by using the input command. So we write a is equal to input, let's say enter a number. Then we do the same thing to read a number b, and what we want to do, we want to check if the number that we have entered are positive or negative, and we have two numbers in our hand. So what we do is this: we write if a is greater than 0 and b is greater than 0. So here we are using AND. This means that A must be greater than 0, which results into true, which is 1, and B should be greater than 0, which is true, and it is 1. Then it means that 1 and 1, the result will be 1, which is true. So we can, let's say, display both numbers are positive. And we can have an else if A is less than 0 and B is less than 0, then it means that both of the statements that we have are negative. Then we can write else, and we can put if. Now, if A is greater than 0 and B is less than 0, then we can display that A is positive and B is negative. Of course, we are assuming that the user will not enter 0 as A and B, but we can include it. Now, we will enhance this code a bit later when we will try to write it in a more professional form. Right now, let's continue by else. If the next condition is that A is negative, B is positive, and then we can display that A is negative and B is positive. And then we can put an end here, an end here, an end here, and end here. Now, you know that in MATLAB is auto-intended, so we can always see whether we have to put another end or not. And let's also save, and we save it as test 5. Now, of course, if you are slightly familiar with the programming, you can see that this is not a very good way of writing the question, a solution for a very simple question that we had. But let's run it first, then we can go back to our code and enhance it together. Now, I'm running it. Let's enter the number, first number to be 5, the second number to be 9, which says that both numbers are positive. Let's try it again. The first number is minus 1.25. The second number is 6.08. And it says that A is negative, which was the first number, is negative. The second number, which is B, is positive. Now, let's get back to our code. And let's go through the code together and see how we can enhance it. If A is positive, and B is also positive, it means that the numbers that we have are definitely both are positive. Now here, when we are coming down and we check that if A is negative and B is negative, and then we check that A is greater than 0 and B is less than 0, then in the last condition for the else, we really do not need to have this if. Why? Because let's see, when we come here, can A be positive and B positive? No, because if that was the case at the beginning, we would just simply have this comment executed. So it means that this last if that we have is definitely a case which will happen if all the previous conditions fail. So it means that we can always delete those that extra if and else comment that we had. So I can do it like that, and let's run it, and let's give a condition which A is negative and B is positive. So I give A is negative, minus 5, B is positive, and it says that A is negative, B is positive, which was the case in here. And let's try with an opposite way. A is positive, B is negative, and it works like that. Now, this program can be also written in another format. I'm sure that you can develop always other conditions. Now, why we wanted to have these conditions, for instance these logic operations, is assume we want to write a new program, and the new program says write a program which counts from number 1 till number 100 and displays the number which are divisible by 7 or by 11. Now, in order to do that, we can always use a new comment which we can talk about it, and this comment is mod comment. For instance, I can write mod 10 and 2, and when I press enter it gives me 0 because we know that 10 is divisible by 0. If I divide 10 by 3, we know that the remainder of the division is 1, so we can use a mod comment. So look what I want to do in here. I write for I from 1 till 100. Sorry, it should be I from 1 to 100. If mod of I and 7 is equal to 0, or mod of I and 11 is equal to 0, so I have a condition, then I can simply display I and I can terminate the program. So it will display the numbers which are divisible by 7 or 11, and the numbers are between 1 to 100. I save it as a test 6 and I run it. Let's also clear the screen. So it gives me, it will display those numbers which are satisfying one of these two conditions. As we start from here, number 7 is divisible by 7, 11 is divisible by 11, 14 is divisible by 7, 21 is divisible by 7, 22 is divisible by 11. Now let's say I want to have all of these ones in a vector form, and I want to display them in a row form. So what I can do is I can define a counter, let's say a counter to be value 1, and then I can say that my vector number with the index of counter is equal to I, and I can increase my counter by 1, and at the end I can display my variable num. If I do, I get that the numbers, which 22 numbers I have between 1 and 100, which are divisible by 7 and 11, and the numbers are, as you can see in here. So this is one of the ways. So here what we have done, we have used an OR logic operator. In the previous example, what we had an AND logic operator, and similarly we can continue and have more logic operators if you want to use it. Now, I hope that you enjoyed today's lecture. In the next lecture, we should talk about polynomials, functions, and finding root and the value of those roots. Be seeing you in the next lecture.